For centuries we gazed into the night sky and pondered our place in the cosmos. The stars above have always inspired wonder, curiosity, and a sense of mystery. Ancient civilizations crafted stories and myths to explain the twinkling lights, but the true nature of the universe remained elusive, hidden in the darkness between the stars. We imagine the universe's beginning as a moment of intense light, the Big Bang. In that instant, all matter, energy, space, and even time itself burst forth from a single unimaginably hot and dense point. The universe expanded rapidly, filling with a blinding brilliance that marked the dawn of everything we know. But after this brilliant birth, a period of darkness was thought to have followed. The initial light faded, leaving behind a universe plunged into shadow, silent and cold, as if the cosmos itself was holding its breath, waiting for the next act to begin. The early universe was a vast expanse of neutral hydrogen, a cosmic fog obscuring the light of the first stars and galaxies. This fog was so thick that it absorbed and scattered any light trying to escape, making the universe opaque and impenetrable to our eyes. Astronomers called this era the Dark Ages. It was a time when the universe was shrouded in darkness, before the first sources of light could break through and illuminate the cosmic landscape. It was a time before galaxies, before the familiar structures of the universe had taken shape. There were no stars, no planets, no clusters, just endless clouds of gas drifting and cooling in the vastness of space. Peering into this distant past was a challenge, like trying to see through a thick wall. The cosmic fog was so dense that even the most powerful telescopes struggled to catch a glimpse of what lay beyond. The light from those early times was faint, stretched and shifted to infrared wavelengths by the universe's relentless expansion. As space itself grew, the ancient light was pulled and reddened, making it even harder to detect. Our telescopes struggled to pierce this veil, leaving the earliest chapters of the universe shrouded in mystery. Scientists worked tirelessly, developing new instruments and techniques, hoping to catch even the faintest whispers from this hidden era. We had glimpses, hints from the cosmic microwave background radiation, the faint afterglow of the Big Bang. This ancient light, now cooled to just a few degrees above absolute zero, offered a snapshot of the universe as it was nearly 14 billion years ago. But the universe's first billion years remained largely hidden from view. The details of how the first stars ignited, how galaxies began to form, and how the cosmic fog finally lifted were mysteries waiting to be unraveled. It was a time we could only imagine, a time of profound change and cosmic evolution waiting to be revealed. The story of the universe's dark ages is not just about darkness, but about the anticipation of light, the promise that even after the deepest night a new dawn would eventually break. Then came the James Webb Space Telescope, our most ambitious eye on the cosmos yet. This extraordinary observatory represents decades of vision, engineering, and international collaboration, uniting thousands of scientists, engineers, and dreamers from around the globe. The Webb Telescope is not just a machine, it's a symbol of humanity's relentless curiosity and our desire to understand the universe we inhabit. Launched on Christmas Day 2021, the Webb Telescope carried with it the hopes of astronomers worldwide. As the rocket soared into the sky, generations of research and anticipation culminated in a single breathtaking moment. For many, it was the realization of a lifelong dream, to peer deeper into the cosmos than ever before and to answer questions that have lingered for centuries. Its mission? To pierce the veil of time and distance, to show us the universe as never before. Webb was designed to look farther than any telescope before it, to capture the faintest glimmers of light from the earliest galaxies, and to unravel the mysteries of cosmic origins. And it did not disappoint. Equipped with a giant gold-coated mirror and sensitive infrared instruments, Webb was designed to detect the faintest whispers of light from the early universe. Its mirror, over 6 meters across, is the largest ever sent into space, allowing Webb to collect more light and see farther than any previous telescope. The use of infrared technology means Webb can peer through cosmic dust clouds, revealing stars and galaxies that were previously hidden from view. It could see what no telescope before it could, capturing light stretched and reddened by billions of years of cosmic expansion. This red-shifted light holds the secrets of the universe's earliest moments, allowing scientists to study the formation of the very first galaxies and stars. With Webb, we weren't just looking back in time, we were traveling through it, witnessing the universe's infancy firsthand. Each observation is like opening a time capsule, revealing how the cosmos evolved from darkness into the brilliant tapestry of stars and galaxies we see today. Almost immediately, Webb began sending back images that stunned the world. Scientists and the public alike were awestruck by the clarity and depth of these photographs, which revealed details never before seen and ignited a new era of discovery. The first deep-field image, released in July 2022, showed a dizzying array of galaxies, some so distant their light had been traveling for almost the entirety of the universe's history. Each tiny speck in the image represented an entire galaxy, some formed just a few 100 million years after the Big Bang. Webb's capabilities didn't stop at distant galaxies. Its sensitive instruments also began probing the atmospheres of exoplanets, searching for signs of water, carbon, and even the building blocks of life. For the first time, we could analyze the chemical fingerprints of worlds orbiting distant stars, bringing us closer to answering the age-old question, are we alone? But it was what these images revealed about the early universe that truly revolutionized our understanding of the cosmos. Webb's discoveries challenged existing theories, forcing scientists to rethink how galaxies formed and evolved in the universe's first billion years. The Dark Ages, it turned out, weren't so dark after all. Instead, they were filled with the birth of stars and galaxies, lighting up the cosmos and setting the stage for everything that would follow. Webb has opened a new window to the universe, and with every image, we are reminded of how much there is still to discover. Webb unveiled a treasure trove of ancient galaxies, hidden for billions of years and now revealed in stunning detail. These are some of the earliest galaxies ever observed by humanity. These galaxies, formed just a few 100 million years after the Big Bang, were far more numerous and brighter than anyone had expected. They glowed with surprising intensity, challenging our long-held assumptions about the early universe. This discovery sent ripples of excitement and astonishment through the scientific community worldwide. The universe, it seemed, was a much more active and crowded place in its youth than we had ever imagined. The galaxies we saw were not the faint, nascent objects we expected to find. These were vibrant, star-forming powerhouses, already teeming with stars and cosmic activity, some possibly even harboring supermassive black holes at their centers, defying expectations. This finding posed more questions than it answered, opening new mysteries. How could these galaxies form so quickly after the Big Bang in such a short cosmic time? What fueled their prodigious star formation rates and rapid growth? The standard model of cosmology, while successful in explaining many aspects of the universe, struggled to account for such early and rapid galaxy formation. The universe, it seemed, had a few more surprises in store for us, waiting to be uncovered. The discovery of these bright early galaxies wasn't the only surprise Webb had in store. As astronomers peered deeper into the cosmos than ever before, they realized that the universe's earliest chapters were far more complex and dynamic than previously imagined. The James Webb Space Telescope, with its unprecedented sensitivity, was not just revealing new galaxies, it was fundamentally challenging our understanding of how the universe came to be. The telescope also detected supermassive black holes, billions of times the mass of our Sun, lurking at the hearts of these young galaxies. These cosmic giants, previously thought to be rare in the early universe, appeared to be surprisingly common, raising profound questions about how such massive objects could have formed so quickly after the Big Bang. These black holes, too, challenged our understanding of how the universe evolved. Their existence in such abundance and at such an early epoch forced scientists to reconsider the timeline of cosmic evolution and to ask whether our theories about the growth of structure in the universe might be missing something crucial. Black holes, regions of space-time where gravity is so strong that nothing, not even light, can escape, are thought to form from the collapse of massive stars. In the traditional view, these stars end their lives in spectacular supernova explosions, leaving behind dense remnants that gradually accumulate more mass over millions or even billions of years. But for black holes to grow to the sizes observed by Webb in the early universe, they would have needed to start forming and accreting matter at a staggering rate, almost immediately after the Big Bang. This rapid growth defies the slow, steady process described by existing models, suggesting that something extraordinary was happening in those first few 100 million years. This presented a significant problem for our existing models of galaxy and black hole formation. Astrophysicists now faced the daunting task of explaining how these supermassive black holes could have assembled so much mass so quickly. and what mechanisms might have fueled their explosive growth. Some scientists began to speculate about new possibilities, such as the direct collapse of massive gas clouds into black holes, bypassing the need for a star to form first. Others wondered if exotic physics or unknown processes in the early universe could have played a role, opening up entirely new avenues of research. These models suggested a more gradual process, with black holes growing slowly over cosmic time as they consume surrounding gas and stars. But the evidence from Webb was clear. The universe's earliest black holes were anything but slow-growing. The presence of such massive black holes in the early universe hinted at a much faster and more efficient mechanism for their formation, one that we didn't fully understand. As astronomers continue to analyze Webb's data, they hope to uncover the secrets of these cosmic behemoths, rewriting the story of how the universe's first structures came to be.